Many people that have been involved in touch in the last few years sort of had experienced a false start with larger projected capacitive screens. 2 or 3 years ago, everybody was saying that every laptop and every notebook that came out was going to have a capacitive touch screen on it. And I think that some of you have maybe experienced that personally, and other people had seen stories about what we would consider to be sort of a failure or a real false start. However, in the last couple of years, there have been significant technical developments in larger projected capacitive touchscreens that now this technology is moving into large touchscreens in many, many different applications. There are a lot of controller features that you see available now that just were not available at that time. Noise problems, speed problems, filtering problems all resulted in a poor user experience. At the same time, there were limited capabilities in real multi-touch for large screens. You know, one of the attributes in terms of making a larger screen more user-friendly is the ability to put your palm or your arm on the screen while you're using it. Well, the early screens didn't have the capability of palm rejection and these things because their multi-touch capability was very limited. This really made the ergonomics of using these devices compromised. In the last 2 years, there have been major technical developments on both the controller technology and also on panel construction that now there are a significant number of manufacturers that are manufacturing, building, designing very robust multi-touch panels in this monitor size. The first thing is really on the controller technology. Some companies are using sort of an off-the-shelf controller technology from some of the big controller companies. Other companies have made decisions to develop their own controller technology. But at the same time, if you really look at the spectrum of controller technology right now, you'll see very advanced features, whether these are internally developed or whether these are off-the-shelf controller solutions. Multi-touch capability has expanded from just 3 or 4 fingers to 10 fingers to 16 fingers to 20 fingers. So you can have advanced features like palm rejection, multi-user capability, multi-touch complex gesturing that can be done on these screens. Now these controllers are configured with very sophisticated advanced features in terms of noise suppression, fast response time, gesture processing, multi-touch capability, all of which have sophisticated parameters for designing the touch experience specific for the application that you want. And the application development, the developers have full access to configuring these controllers to get a very rich touch experience. At the same time, not all of the technology has been focused on the controller side. A lot of it has to do with the actual panel, touch panel, or touch sensor. One of the things that has happened is that on the material side, new generations of ITO coating, adhesive systems, index matching have all made these new larger touch screens so that they are virtually invisible or are unnoticeable on these applications. Many of these new touch sensors now are self-shielding, so noise from the TFT and outside noise, these touch screens are self-shielded, so you get much better, more robust touch experience. In industrial applications, medical applications, and some of the more demanding applications, mechanical robustness is a very critical part to the solution. Every application that historically either had a no-touch environment or a resistive touch screen are now looking to projected capacitive touch screens. Some of the things that we see that our customers in the market are really demanding They really want fast touch response and low latency. This is really critical for their application. They want good noise immunity, high signal strength, good signal-to-noise ratios for very, very robust touch. And they really do want true multi-touch so that they can design applications for these large screens that are user-friendly and fit the ergonomics of their application. They also want high impact resistant. They want a hard scratch resistant surface. And all of these advancements that have happened in small capacitive touchscreens have all been moved out into the larger touchscreens. They all want a cost competitive solution. Through these advancements, you've seen projected capacitive multi-touch screen. The cost differentials between this technology and traditional touch technology has narrowed substantially. Optical bonding of the touchscreen to the TFT is now becoming almost a de facto standard in terms of getting good optical performance out of this system. So we're finding lots and lots of, most of our customers are demanding optical bonding. At the same time, panel design and controller technology have implemented self-shielding designs for noise immunity. A couple of concluding remarks. The technical advancements that have happened over the last couple of years are really driving PCAP to be adopted in just an entirely wide spectrum of applications. We see it in just virtually every application that you can think about, and this adoption of this technology has really been is really because of the advancements on the controller and panel construction that have happened over the last couple of years. Thank you very much.